This video is an introduction to trigonometry. Before we start trigonometry, we must look at labelling of right-angled triangles. In trigonometry, we usually have an angle that's being asked for or is given, and we label that angle theta. It's an acute angle, less than 90, symbol's a bit like that. And it's the nominated angle that we're dealing with in the right-angled triangle. Now, opposite that given or requested angle is a thing called the opposite. And as the name suggests, it's opposite the theta, or the angle given. The longest side in the triangle is the hypotenuse, and the adjacent is the angle next to the given angle, or the required angle, and not the hypotenuse. Okay, so that's the adjacent. So that's labelling of triangles. In trigonometry, we've got three basic definitions. These are called trigonometric ratios, or trig ratios for short. Their longer form names are sine, cosine, and tangent. We usually shorten them to sine, cos, and tan. There's rules for each of these ratios, okay, and they're used in triangle calculations, both non-right-angled and right-angled. We'll be concentrating just, though, on right-angled triangles. So the first rule is that sine of the angle equals opposite over hypotenuse. The second rule is that the cosine of the angle, cos theta, equals adjacent over hypotenuse. And the third ratio, tangent or tan theta, equals opposite over adjacent. Now there's a little rhyme here, or mnemonic, SOHCAHTOA. If you remember that, it gives you the three ratios. Sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tan equals opposite over adjacent. So by remembering that little rhyme, even though we will be provided with these ratios in a test situation, you can remember them. Before we go any further, we need to look at putting angles into our calculator. Now, angles can be divided, as you know, there's 360 degrees in a full circle, and those angles can be further divided into minutes and seconds. A bit like an hour is divided into minutes and seconds, so is a degree. So there are 60 seconds in a minute and 60 minutes in a degree. So for an example, you can express an angle as 50 degrees, 33 minutes, 48 seconds. Now, for our purposes, I'm only going to go to degrees in minutes. Okay, I'm not going to go to the seconds level. But before we start doing calculations, we have to work out how to put something like cosine 65 degrees, 57 minutes into our calculator. Casio calculator looks a bit like this. Okay, and it's got a very important button, the degrees, minutes, seconds button, which has got a little circle and then 3 commas. It's also got the trigonometry buttons here, sine, cosine, and tan, which we use a fair bit. So the cosine, sine, or tan of a number is represented as a decimal number, and we're going to go to 4 decimal places. Okay, so here we've got cosine 65/57. Now, that's not the readout for that, I realise that, but I'm going to take you through this very slowly. So the first thing you do will be press the cosine button, followed by 65, and I'll do this too as we're going along, followed by 65. Then we press the degrees, minutes, seconds button, okay, and you should see a readout now with 65 and a little square there, attempt to do a degree sign. Then we put in 57. Okay, and we press the button with the commas, the degrees, minutes, second button again. And then press enter, and we get to 4 decimal places, 0.4075. So that's the cosine of that angle. Okay, so that's a pretty important skill we need to learn straight away. All right, let's move on. You can practice that. With your own angles to get that 4-digit or 4 decimal place number. Okay, so the opposite of that is finding angles. So we've got a sine value and we have to actually find the angle. So this time it's a little bit different, okay? We actually have to press the shift button first, okay? So if you notice, if I go back a couple of slides, one slide, there's the shift button there, okay? So to find the actual just going back. Okay, to find the angle here, we have to go Shift. Because it's got sine as one of our ratios, or our ratio, Shift sine. Okay, so we go Shift sine. Okay, and then we put in 0.7854. 0.7854. So Shift sine 0.7854. And the readout I get when we do that, okay, so 0.7854 is 51.75768852. And that's the number of degrees, but that's expressed as a decimal. We actually want our angle in degrees and minutes. So what we do now is we actually press the button with the degrees, minutes, seconds button, so that one there. And if you press that, we get 51 degrees, 45 minutes, and 27 seconds, 27.68, but we'll just go to 27 seconds. Now, we're not too interested in seconds in this unit. So what happens is if that is 30 or below 30 seconds, we leave it as it is. So it would stay as 51 degrees, 45 minutes. If that had been 30 seconds or more, I would have gone up to the next minute. Because remember, there's 60 seconds in a minute. So when you're rounding here, 30 is the cutoff mark. Anything greater than 30 seconds, you take it up to the next minute. Okay, so the angle that has the sine of 0.7854 is 51 degrees, 45 minutes. We go Shift sine 0.7854, decimal answer, then press the button with the commas on it. So now I'm going to write down some rules for this triangle. And I've put to the right here the abbreviated form of the rules. Okay, so first rule we're going to look at is sine theta. Now, before we go any further, we're going to label this diagram opposite, OPP for short, hypotenuse, HYP for short, and adjacent, ADJ for short. Remember, opposite is opposite the theta, hypotenuse is the longest side, adjacent is next to the theta. So sine theta is opposite over adjacent. Our opposite is A, our adjacent is C, so sine theta would be A over C. Cosine theta, okay, is adjacent over hypotenuse. The adjacent is B, the hypotenuse is C, so cosine theta would be B over C. Tan theta equals opposite over adjacent, so that's A over B. Okay, so there are the three ratios for this given triangle. Next one, write an equation that relates the two marked sides and the marked angle. Okay, so first thing we have to decide is whether this is going to be sine, cos, or tan. Now, what we're going to look at here is what of the three sides are we given. So there's our angle B that we're given. Okay, that's our theta if you like. And we're given the opposite, so OPP. And we're also given the hypotenuse, which is 12. So because we've got opposite and hypotenuse, we look for the three ratios, look through the three ratios, and see which one involves opposite and hypotenuse. And straight away I can see that sine involves opposite and hypotenuse. So my rule here is sine theta, okay, side of my angle is called B, okay, so that's my theta, equals opposite, which is 8, over hypotenuse is 12. Now later on we're going to actually solve these, but for the moment we're just getting the equations. Next one, okay, so my theta is 40 degrees, it's the angle I'm given, or trying to find. X is my opposite, okay, that's the hypotenuse there, and that's not labelled, so we ignore that. And the other one, obviously, therefore, is the adjacent, the one next to the angle given. So this question involves opposite and adjacent. Which rule involves opposite and adjacent? It's tan. So tan of the angle, theta, our theta is 40, equals opposite, which is x, over the adjacent, which is 22. And there's our rule that links the sides and the angles. As I said, later on we'll go on and solve those equations to find the sides and the angles. That's coming up next. Hope that's a good start for you in trigonometry. Bye for now.